Now, I'm going to go out there on a limb and make a guess, and that is this. When people are running a virtual machine on an ESXi host, when companies are doing that, it's because they want that virtual machine to be running and available. Is that pretty safe? I think it is. Well, what happens if this VM, let's call this VM-1, it's running happy on this ESXi host 2. What happens if this ESXi2 host goes belly up, completely out of commission? Well, if the host goes out of commission, the VM is also out of luck. And also, short of the entire host failing, maybe the host loses its connectivity over to the storage network. So the host is still running, but it simply doesn't have connectivity to the storage anymore. That also would be a problem for this VM. So a solution that VMware has on the table as part of vSphere is that we can use a feature called HA, High Availability. And we can enable it at the cluster level. So if we have these 3 ESXi hosts, they're all in a cluster, we can enable high availability on the cluster. And then what happens is if there's a failure on one of these ESXi hosts, the cluster is going to detect that. And a VM that was running here on ESXi2, if it's no longer responding and available on the network, that VM will be restarted over on one of the other ESXi hosts. Let's say, for example, it's started here. So with high availability, it's watching and protecting against an ESXi host failure, and it's going to restart a virtual machine on another ESXi host in that cluster so that that virtual machine can be up and running again. We also have options with high availability of monitoring a VM itself. Because this machine is running VMware tools, we can do heartbeats to that virtual machine. And let's say the guest operating system just locks up. It's no longer functioning. We can go ahead and detect that if we enable that feature of VM monitoring and restart that VM. And we'll just restart it on the same ESXi host. So we can protect against host failure. We can also protect against an individual VM that is locked up and is no longer responding. There's also the option of monitoring a specific application that could be running on a virtual machine. And if it stops responding, we could also restart that virtual machine, which would restart the apps to get it up and going again. So one of the key elements that's used in high availability is the concept of a heartbeat. And from a host perspective, what happens when the cluster comes up, one of these ES6i hosts is going to win the election as the master from the perspective of high availability. And there's a set of criteria regarding who's going to win. And I think one of the initial criteria is which ES6i host has access to the most data stores. And then if those are all equal, it goes on to some other criteria. But at the end of the day, one of these ES6i hosts is going to become the master in high availability. And for our discussion, let's go ahead and say it's ES6i3 who is the master. And effectively, this master is going to be keeping track of the other 2 ES6i hosts with heartbeats. And those heartbeats are going to go over the management network. And to help prevent against false alarms and also to help prevent a total shutdown of the management network, we might want to have some fault tolerance. And we do. In our topology, we added NIC teaming to the virtual switch that's supporting the VM kernel port that's enabled for management. So we have 2 paths, 2 physical uplinks supporting the management network from each of our ES6i hosts. So even if we lose one of those physical connections on an ES6i host, because we have redundancy there, that heartbeat over the management network can still continue. So let's play what if. What if ES6i3, sending out the heartbeats, no longer hears from ES6i2 over the management network? It hears from ES6i1, but it doesn't hear from ES6i2. Now, what are the possibilities? Well, the possibilities are ES6i2 has crashed, it's not responding to anything, or maybe ES6i2 just had a significant network failure. So hopefully we had redundancy, but let's say even the redundant network link fails. ES6i2 is still running its VMs. It just isn't responding over the management network. So we could have a situation where ES6i2 is up and running, and it's supporting its VMs just fine, but fails to respond over the management network with the heartbeats. So to help assess the situation regarding ES6i2, in addition to heartbeats on the management network, there are also data store heartbeats. vSphere is going to identify 2 data stores to use, and then periodically each of the ES6i hosts is going to write and modify a file on those data stores. So in our example here, if ES6i2 with a management network failure still has connectivity regarding storage over to the storage network, and it's updating periodically these files on the data store, ES6i3 can check that as well, and it can look for ES6i2 files and look at the timestamps and say, whoa, ES6i2 is still writing to the data store. It must not be dead because it's doing those periodic updates of a file that's representing he's still alive via the data store heartbeats. We have an isolation event. ESXi2 is not crashed, but certainly we have some isolation on the management network. So now that ESXi3 realizes that ESXi2 is basically having an isolation event where it can't communicate. And ESXi2 is also definitely aware that it's not seeing those heartbeats. And so what ESXi2 will do as well, it'll try to ping an address called the isolation address. And by default, the isolation address is the default gateway on ESXi2. We can configure it to be a different address, but by default, that's what it is. So when ESXi2 is not seeing the heartbeats, and it cannot ping its default gateway, or the isolation address, it knows it's having an isolation event. It's like, oh no, now what do I do? We have some choices regarding high availability of what we want to do regarding the VMs that are currently running on this ESXi host. Another problem that could come up for an ESXi host, and we'll pick on ESXi2 again, is what if it loses connectivity to the storage network? So this VM1 is happy or was until the host lost connectivity to the storage network, which is going to impact this VM because all the files, including the configuration file and the hard disk file or files regarding this VM, are over here on the data store, which ESXi2 can no longer reach. There's a feature called VMCP, which stands for VM, Virtual Machine, Component Protection. And effectively, what it's looking for are problems between the ESXi host and the data store. And through VMCP, we could identify that we have a permanent device loss, meaning we had some connectivity to storage and it's not coming back. And the acronym for that is PDL, Permanent Device Loss. Another aspect of VMCP is called APD, which stands for All Paths Down. And these both relate to storage. So a good way to think about this is that the all paths down is transient. For example, maybe there's an intermittent failure across the network, but yet the network interface card and the other components on the host are working, and perhaps that connectivity is going to come back. And looking at our topology, wouldn't it just be like one path down because that's all we have to our data store? But we could have some fault tolerance, and we'll talk about that in a separate nugget. We could add fault tolerance for our iSCSI connectivity as an example. And then if the storage processor has a problem or there's a network connectivity issue for a period of time, even if we had redundant connections, we could still have an all paths down while the ESXi host is trying to figure out how to reach that destination. So all paths down is more transient in nature, and permanent device loss means we need to do something different. And these are both aspects of the virtual machine component protection. And the idea is that if we do have an issue with PDL or all paths down, if it's happening to ESXi2, it's very likely that we're going to want to take some action regarding the VMs that are running on ESXi2, or we may decide we just want to reboot the ESXi host and hope for the best. So we can configure those options as we enable high availability on the cluster and then set those options the way we want them. So in this nugget, I wanted to chat with you about the features and functions of the high availability, and in the next nugget, I'll walk you through the hands-on lab in implementing it. Until then, I hope this has been informative for you, and I'd like to thank you for viewing.